Today we are going to write equations in two variables. And the first example, or first question, asks us to give the values in each table. Given these values in each table, we're supposed to write an equation and then also figure out what this missing value is. And so what you have to do is compare the x values to their corresponding y values. So look at the 1, and how do we get up to 7? Well, we could do it two different ways. We could either do 1 plus 6 equals 7, or we could have done 1 times 7 equals 7. And so then we have to go to the next one and see how they went from the 2 to the 14. How do they go from 2 to 14? Well, if we added, we would go 2 plus 12 makes 14. Notice that those are not the same. See, here we added 6, here we added 12, so that's not right. So that's not the way the equation is going to go. So let's take a look at the other way. Over here we did 1 times 7 made 7, so let's try the same thing here. Let's do 2. 2 times 7 makes 14. Oh, that's true. You see how this works? So let's try the next one. How did they go from 3 to 21? We know we can't add numbers because they'd be different each time. So let's try coming up with the same value to multiply by 7. And yes, 3 times 7 does equal 21. Look at the next one. It's 4 times 28, or 4 times 7. So let's fix that real quick. So 4 times 7 does equal 28. And so yes, we figured out the rule. The rule is you're multiplying by 7 each time. And so that's what you have to do, is look at the x's and see how could you get to the corresponding y value. And do that for each of the problems and see which pattern is consistent. Here it's timesing by 7. So our rule would be this. The y value, which is this number on the bottom here, equals 7 times the x value. And that is our answer there. So we have y equals 7 times x. See, the value of y, and if is, like for instance here it was 7, if we take 7 and multiply it by the x value, x here, we get the y value. So this is the equation that matches that rule that we were talking about each time. So you notice that this was an x value here, this 1, and the y value was 7. And so here the x value was 2 and the y value is 14. Here the x value is 3 where the y value was 21. Here the x value is 4 and the y value is 28. So this is the equation that matches what we were doing with all of these 4 problems. So that's the first step. So then the next step is to indicate the value of x for this, indicate the value of y for this value of x that we have. So what we're going to do is just substitute. Put the 5 in place of x and then solve. So y equals 7 times by 5, which makes 35. So there it is. Y is 35. So we'll just put 35 right up there and circle that answer. Let's take a look at our next one. Again, so you're starting with the x and you're seeing how did they get to -3. So let's try a few different ways here. Well, one way, they could go from 2 and they have to equal a -3. How did they do that? Well, they had to take away something. They had to take away quite a bit. Let's take away 5. If we take away 5 from 2, that would be at -3. Okay, that's one way to get there. The other way, well, would be dealing with fractions. And so the other way would be like going 2 times by what equals -3. Well, that means I would have to cancel out a denominator, and I'd have to have 3 on top. So that's the other way it would end up working. See, the 2's would cross-cancel, and you're left with -3. So those are the two ways we're having to come up with that. The other way would be 2 plus -5 equals -3, but that's the same. These are equal. And so let's go ahead and take a look at and see which one matches this next one. So we're starting at 3, and we need to go to -2. Alright, so let's try this way first. If we minus 5, does that get us to -2? It does. 3 minus 5 does make -2. Let's try the next one here. 4 to -1. So 4 minus 5, does that get us to -1? Yes, it does. So here, -5 seems to be the number, the rule each time. Let's try this last one though. 5 minus 5, does that equal 0? Yes. So that's the rule. We're taking 5 away each time. Take 5 away each time. That is the rule. And so to write that out, I'm going to start with my y value equals, And then I'm going to go to my x value. I put in my x, I'm plugging in the x value, and I take away 5. And this is the rule that matches what I've done with each of these problems. Again, this was my x value initially. I took away 5. See, x minus 5 is right here, and it equals my y value, which was negative 3 in this case. So equals y. So that is the equation. Now what we want to do is find out what 6 would be if we put that in for x. So we're going to substitute 6 in place of x. So it's y equals 6 minus 5. Well, that would equal 1. So that is the missing number there. Well, the next set of directions asks us to write an equation for the relationship. We also have to tell what each variable you use represents. So it says Amanda is. Whenever I see the word is, I think of equal. I think of was as equal as well, but here I have is, so I'm saying equals. Amanda is 7 years younger. Younger. Okay, when I see the word younger, I think of minus. It tells me minus. Then her cousin. Okay, so let's talk about our unknowns here. So our unknowns are going to end up being the cousin and Amanda. So let's go ahead and assign some variables. I'm going to call Amanda A. So I'm going to say A equals Amanda. And I'm going to say C equals cousin. So this will be C. So that's the cousin. So those are my variables. So I have defined my variables now. Now I'm going to write an equation. So Amanda is, so as I said before, I'm going to write down A equals 7 years younger. So that means I'm going to take away 7. So let me write that part down there. So 7 years younger means minus 7. So I'm going to take away 7 from the cousin's age, C. So there it is. Amanda is 7 years younger than the cousin. So I have to have it this way, otherwise I'd end up with a negative number, because Amanda has to be older than 7 years unless Amanda was 0 years old. So let's take a look at the next one here. The population of North Carolina is twice as large as the population of South Carolina. So what are the unknowns? Well, the unknowns are North Carolina's population and South Carolina's population. So let's write those down. N equals North Carolina, Carolina's population. We use POP for population there. And we'll say S equals, how about South Carolina's population. Alright, so we've got our variables defined. Now let's try to write it. So North Carolina is, see that word is? Let's use an equal sign. So N equals twice as large as the population of South Carolina. Twice means 2 times. Another way to say that is double. So 2 times. 2 times by S. And if you put a multiplication sign in between, that's fine, a little dot. Or you could just have them right next to each other, and that works as well. Now, taking a look at our next one, it says that an internet company charges $7 for each paperback book, plus $2.75 for shipping and handling per order. So $7 for each paperback book. And plus, so obviously that's a plus sign, $2.75 for the shipping and handling per order. So per order means if we just order one time, this is like a constant amount. So we're definitely going to pay this for each order. But if we're only talking about one order, that's a constant. There's no variable attached to that. So let's find out what our variables are going to end up being. Let's say that an internet book company, let's go with the cost. Let's use C as the final cost. And let's call, it says each paperback book. We don't know how many paperback books we're going to buy. Let's do P equals the number of paperback books. So those are the two unknowns. We don't know how much we're going to spend. We don't know how many books we're going to buy. So now let's go ahead and write it down what we're going to have. So we're going to have a cost is going to end up equaling, and then we've got a $7 for each paperback book. Again, we've got an unknown here of paperback books. We don't know how many. So this is our variable amount right here. The variable amount is what gets multiplied. So this would be 7 times by P. So 7p, so 7 times the number of books plus, because they use the word plus right here, $2.75 for shipping and handling per order. Well, we're only talking one order here, so that would be our amount right there. And we've defined our variables down below. Looking at our next one, it says that we have Henry records how many days he rides his bike and how far he rides his bike each week. So how many days, and how far he rides each week. So those are two things. Let's continue reading. It says he rides the same distance each time. And so that's important too. He rides the same distance each time. And he rode 18 miles in 3 days. So let's write that down. 18 miles is every 3 days. So this is a distance, miles and days. And then he did 24 miles in 4 days. And then he did 42 miles in 7 days. So we need to figure out how did they go from 3 to 18, 4 to 24, 7 to 42. And so let's see if there's a rule there. Well, let's start at the 3. So 3 times by 6 equals 18. Let's see if that rule maintains with all these other ones. 4 times by 6 equals 24. You see how they're equaling there? 7 times by 6 equals 42. So we've figured out our rule. Timesing by 6 is the rule. So that's our rule, is to multiply by 6. So now let's define some variables. Let's say that, how about D equals the number of days, and we'll say that M equals the number of miles. Because those are the two different things we're talking about, miles and days. And so what I would do is, I'd start off with the number of miles equals, and then if I do the number of days times by 6, so 6 times the number of days. So M, the number of miles, equals 6 times the number of days, and that matches what we did here. So the number of days was 3 times by 6 equaled the number of miles. M is 18 there. So the number of days, 4 times by 6 equals the number of miles, 24. Number of days, 7 times by 6 equals the number of miles, M. So that ends up matching our equation. All right, well, those are the types of problems you're going to see on tonight's homework. Actually, I've got one more I'll go ahead and throw in here. Ed charges $150 plus $40 per hour. So let's just write it out. We'll just say that Y equals the cost, and we'll say X equals the number of hours. And I could have called it C and H. It doesn't really matter. So it's going to just be Y equals the cost of $150, that's a constant, plus $40 per hour. And X was the number of hours. So there would be my equation. So you'll see a couple of problems just like that where they don't have any words to them except for just a little sign, and then you just have to figure out what the equation is to match. And that's an example. Well, good luck on tonight's homework.